All right, so this is just going to be a quick tutorial on how to work on F1Tenth projects using Docker, and also just an example of a workflow you could possibly follow. All right, so I'm just going to start off by running up a command prompt and navigating to where I have cloned our autonomous crash course repo. So you should probably have this cloned by now. So now I'm gonna just go into our Docker setup folder. All right, so the first step we're gonna do is we're gonna build an image from this Docker file that we've set up. So let me just show you what this Docker file actually looks like. All right, so at the start, what we're doing is we're pulling a base image that's actually been made by Roz. So we get all the stuff they've done, and then we're also going to do some more stuff to it, which is just some more requirements for us. So this bit is just installing requirements for Roz, and also then at the end, just a couple of requirements that we're going to need. And then here we are pulling a few scripts actually from our autonomous crash course repo. It's better to just actually pull them straight into the Docker image. And then finally, we're cloning the F1Tenth repo as well, because we're going to use that to run the simulator. All right, so the command we're going to use to build it is docker build and then -t, which is for tag. And I'm going to call it, we can call it whatever we want. I'm just going to call it F1Tenth. We're actually not really going to be using this tag again, but it'll help me to explain why we're not going to be using it. All right, so this step is obviously instant for me, but if this is your first time running it, it could take even an hour, or it could take 10 minutes. It depends kind of how much Docker stuff your computer has cached. So I have everything cached because I built this earlier today as well. So everything's cached. So it's an instant build for me, but don't worry if it takes long for you. If like midway through while all this stuff is running, it stops and you get a weird looking error, go and check your C drive and just make sure you haven't run out of memory. And yeah, you might just need to free up some space. And if you have run out, don't panic or anything, because it's all just cached stuff. So if you restart your computer, all that memory will come back. All right, so let me just have a look at what we've actually just done. Okay, so this docker ps command, that shows what containers we have running. So obviously there's nothing there. So if I put in -a, which is for all, it'll show us all of my containers. So obviously have a good bit here, except and there's still nothing new here. Last one I had was 2 hours ago. So, and that's because we've built the image and we've called it F1Tenth, but we haven't run it yet. And this first bit we're only ever going to need to do once. So we're going to need to say docker run -it F1Tenth. And this is pretty much the last time we're going to be using this tag here. Okay, and now we're in. So I'm in a Ubuntu OS, basically, just running on Docker. Except this, I'm only going to do this once. Now I'm going to Control D to get out of this, and I'm going to go to start doing what your workflow would be from now on. Okay, so you don't necessarily need to be in our repo. So just to avoid confusion, I'm going to completely start from scratch and open a new command prompt. All right, so I'm going to do docker ps again, and you can see there's no containers running, except since last time we've run that last one, which basically just sets it up initially, except it's stopped now. Okay, so now here it is. You can see it's got the tag F1Tenth, and it was created 48 seconds ago. And now the interesting thing about Docker is, so actually, just to make this more clear, I'm going to bring this out a bit. Yeah, so the image is called F1Tenth, but the name of the container Docker actually gives us, and it basically generates a random name just so that they're all unique. And so this time it's given stupefied Turing, which is pretty fitting because I guess that kind of describes me, Alan Turing, but stupid. All right, so stupefied Turing. So that's the name of our container. So luckily that's pretty memorable this time because I'm not gonna have any problems running the next few commands. Sometimes it's something horrible like this, and then I have to memorize that. But with this stupefied Turing, should be all right. Okay, so all right, so let's start up this container. So docker start stupefied Turing, and the thing is, the reason we need to use the container name is because there could be multiple with the same image name, like these, for example. These both have the same image name. So we can no longer use F1Tenth to know what it is. We have to use the name that Docker's given us. So in our case, it's docker start stupefied Turing. All right, so let's check, make sure it's started. And there we go. So we can see our container is now started, but we are not yet attached to it. And so basically we say docker attach stupefied Turing. And what this is going to do is it's basically going to put us in the bash terminal of this Docker container. Okay, so we're in again. So now this is kind of our main thread, you could call it, because if we exit from this terminal, we will exit the whole container. So if we have it soon, I'm gonna start up some more terminals, and you could exit those and it would stay running. But if we exit on this main thread, all of the other terminals will also close. So just keep that in mind for if you're ever closing terminals. All right. So we're in now, except we need to do some things to initialize the container. Okay, so the ROS commands aren't automatically ready to use. We're going to need to initialize it. So one of the scripts we pulled in is this one here, ROS init, and basically all that does is it executes this setup.bash file, but it's in kind of a nasty place, so it's kind of easier to just keep it in a script. So source rosinit.sh, and then let's just test out the ROS CD. Okay, it worked. It takes us just into the setup files basically, but at least we have the ROS commands working now. Okay, so next I'm gonna just set up the display. So basically what I mean is allow the Docker image to run a display window on my host computer. And the reason I'm doing that is because we're going to be doing this run simulator script, and that's going to run the F1Tenth simulator for us. but we need to give it an avenue to show some display so we can see what the car is doing, etc. And from within Docker, we just need to do a couple of things to allow that connection through. So I'm just going to be doing obviously the Windows version. Both tutorials are here in our Docker guide for Mac users. And yeah, so the first step of the Windows one is I'm going to open up another command prompt, and I'm just going to do an ipconfig, and I'm going to take my local IPv4 address. This is local, so I don't think you can hack me, but if you can, please, well, actually, I don't think you'll find anything very interesting. I'm pretty boring. So yeah, so we have this other script here, set display. So we're going to use that, and we'll say source set display.sh and just paste in that IP. Okay, so the next step then is xlaunch, and this basically is just going to actually run the window itself that will show us the simulator. And the only non-default thing we do is tick this no access control bit. All right, so you can see down here that we have an X server running now. And finally, I just need to take off my firewall because that would see something coming from an unknown, which is the Docker container, and it would stop it. All right, so we should be ready to go now. So let's just go ahead and run the simulator. So we have that also in a script we've set up, which is just run simulator.sh. Actually, I'm gonna put a slash in front of here because that basically just means you're running it from the root directory. So basically what that means is I could be anywhere in this container, I could be in one of these folders, but I can always just run this and I know that the simulator is going to run. All right, so hopefully this works. It looks pretty at least. Just a lot of dependencies involved with the simulator, but once it's up and running, it works pretty well. Okay, so you can see the only error we get is that it couldn't open a joystick because I don't have one set up. I guess if you're like a retro gamer, you might have one. All right, so the simulator is running now, and it's opened up on our X server that we set up. So that's sweet. So now, well, the car's not really doing anything, so that's not great. So let's go to the next step, which is set up a second terminal so we can run stuff. So what we're going to do is start up a new terminal. So it's a different command this time because this main thread is already running. So what we're actually going to do is we're not attaching to it this time. What we're actually doing is we're running a command on the Docker container, and the command we're running is bash. So we're running a command, but it's basically like we're starting a new terminal. And what allows us to continue to interact with it is this -it, which just means obviously interactive. So it's going to be docker exec-it, and then what are we? It's stupefied Turing. And finally, the command we're going to run is bash. This might take a second. I think the first one takes a couple seconds, but then usually it's just instant after that. It also might be because the simulator is running. All right, we're in. So then, same thing again. Anytime you start up a new terminal, you got to do this ROS init. Okay, so let's attempt to, so basically, let's have a look in this run simulator script and see what it's actually doing. Okay, so basically what it did is we have these things called Catkin workspaces, and that kind of just puts everything together, gathers all the packages, and sets everything up. So the start of this script is just to move into this Catkin workspace that we have set up, and then it runs the catkin make command, which basically just sets up everything in that catkin workspace folder. So I'm just going to show you what's in there quickly, because this is something that we actually pulled in when we were creating the Docker container. We pulled this repo from Git, and in here is all the stuff to run the simulator, except we still need to do that catkin make command once, just to build all that together and allow us to run it. And then once we've done that, what that does is it actually creates this file here, the setup.bash file, and then once we run that, that's actually what updates our ROS basically to have everything together. So in our case, we have ROS CD because we've done the ROS init command, but we do not have so like this simulator is running in the package F1Tenth simulator, but it's not recognized that yet. So what we need to do is, and the reason for that is because we haven't run that script in our catkin workspace, which gives us all the information. So let's run that. So it's source devil/setup.bash. And now let's try that again. So ROS CD F1Tenth simulator. And so you can see one of the good things about ROS is no matter where you are, you can always run these kind of useful commands, and this one just brings you straight into the F1Tenth package. So that's just a quick example. All right. So the next step will be to get some of our own code in there so we can start working on projects. All right. So I'm going to go back into that catkin workspace, go into the source, because this is where our previous repo is, and I'm actually just going to clone my repo for lab 4. So this is private anyways, but oops. Let me get the simulator. All right. So yeah, that's it's my own project basically. But yeah, so this is kind of my workflow. I'll have a Git repo for each of my labs, and then I will just clone them into my catkin workspace. So I'm gonna go ahead and do that. Okay, so again, we're not, my package isn't going to be in there yet, so I think I called mine reactive method. Oh, did I? Oh, yeah, so it is there. That was a bit unexpected. Anyways, I guess that saves some time. So, alright, so let me see if I can run that anyways. So basically my package is in there, and so yeah, I'm ready to go. So let's just have a look at what's actually in that folder I cloned in. So it's just called F1Tenth lab 4, that's just what I called it. And then in the source, we have this reactive gap follow. Okay, so I'm gonna need to run ROS run the name of my package, which is reactive method, and then the name of the source file I'm trying to run. Okay, so it's running, but the car is still not doing anything. I'm actually just gonna move it over here for the purpose of the demo. And so basically, I'm telling the car to do all the stuff. It's not listening yet. I just need to press the letter. I need to go back into this one and press N, which just says navigate mode on. So it's going to start listening. So here we go. Hopefully the live demo doesn't fail me. It's not the most beautiful implementation. Oh. All right. I'm not bothered editing that out, but let's go again. I believe it can do it this time. All right, so I just gotta hit N again. Yeah, maybe don't have me on your team then. Okay, it worked this time. So let's just forget about that one. I think he just leaves. I think it just leaves then. I don't know who made this map, but someone just made a big gap, so he just leaves. But anyways, you get the message. Basically, this is kind of just the workflow I'll do. So I just killed both of them there, and so yeah, the last bit of the workflow is, okay, so I'd have the simulator running. I could have my lab down here running it, and then I'll actually have another terminal, which I'll edit my code in. So all right, I'm gonna see if I can just do all this rapidly then, because you've seen enough. All right, so I'm just running up another terminal. Let me just get this positioned nicely. Come on. I don't know. Yeah, all right. Sometimes it just takes a couple seconds. All right, so the first step is ROS init, obviously, and then I'm gonna go into my, see, I can use ROS CD to just go straight in to my package if I can type it correctly, the most difficult part. Oh, no, I can't because I haven't done the cat can work space, but yeah. So I just need to source that file again. Can I remember it? The path, yes, I can. Okay, so I'm gonna, like I hoped last time, just CD straight into my package. There we go. So now I'm actually gonna switch the position of these two. This is the way I do it. So I have the simulator running there, and now I'm gonna have my, not that, close, boom. All right. That's the hardest part. I just hit the keys randomly and hope it gets to the right spot. There we go. All right. So let's have a look. All right. So I just have my code up here. Don't need to worry about that. That's just a Vim thing. Okay, so I'll have my code here. No peeking. No, just kidding. Feel free to take whatever you want. It's not that great. Um, and then yeah, so I can make changes here. And then I just save it, go straight down here, run it, go up here, and hit N, and it's going. So yeah, you can get pretty quick at with this workflow then. All right, so the last bit I'm going to show you is just the end, basically. We're done. So this was just my root one, so I can actually just exit this, and as you can see, these have all actually been exited. Otherwise, I could have exited one of these first, and then their other two would have still been running. But if you exit on your root, then you can just close these, and we're all good. And so now the Docker container is not running anymore, but all our work is still there. So anytime we want, it's all still there in stupefied Turing. You just start again and go Docker start stupefied Turing. And yeah, you get the point of that. You can take that spelling. Yeah, you just all the work's still there, all the folders are still there, and you can continue. So yeah, that's it for today, homies. You can tell I won't be starting a vlogging channel anytime soon because I'm not very good at this. But yeah, enjoy the workflow. Let me know if I did anything stupid, and let's win F1 10th.